So broadcasting is a very important concept in Numpy. Uh, it is like you have Numpy array of a certain dimension, let's say dimension m cross n, and you want to multiply or add some scalar into this multi-dimensional Numpy array, or you want to add another Numpy array which is not exactly of dimension m cross n, that is the original array, but some other dimension. So Numpy supports broadcasting. It's a very powerful thing, especially in deep learning, and we are going to see how broadcasting works with the help of some examples. So first, let's start with a one-dimensional array. I already have written the code. I'm going to just paste it to save your time. Okay, now I'll explain this code. So as usual, I have imported the Numpy. I have set up a seed so that Numpy can make reproducible results. Then we are going to set a new Numpy array. This is a Numpy array of 1 row and 3 columns. You can see this 3 here. Okay, so basically think of it like as a vector, and all the elements in this Numpy array will be between 1 and 25. Now I have taken another scalar b equal to 1, and I am going to add a with b. So now let's see how the results will look. Okay, so the original array is 9, 16, 14, and I have added 1 into it, so 1 will get added into each and every element. Okay, so it will become 9 plus 1 10, 16 plus 1 17, and 14 plus 1 15. Okay, so this is a broadcasting operation. You have broadcasted b along with the whole original array. Okay, so that's a very simple and basic example of broadcasting. So now I am going to show you another example. As you can see here, we have a Numpy array of 2 rows and 3 columns. Okay, what we are going to do now is we are going to create another Numpy array of 1 row and 3 columns. So see, there are 2 Numpy arrays. The first one is 2 row and 3 columns. The second one is 1 row and 3 columns. Now we will add them and see how the results will look. Okay, so this is the 2 cross 3 Numpy array, 2 rows 3 column. Okay, you can see 2 rows and 3 columns, first column, second column, and third column. Then 1 row and 3 column. Okay, now when we add them, what will happen? Each and every element from this 1 row and 3 column matrix will add to each row of the 2 cross 3 Numpy array. Okay, so 8 gets added to 9, it becomes 17. 3 gets added to 23, it becomes 26. 18 gets added to 12, it becomes 30. Similarly, again this row will add to this second row, and its result will come here. So this is how broadcasting works in a multi-dimensional array. Okay, so I have shown you 2 examples of broadcasting: multiplying a multi-dimensional array with a scalar, multiplying a multi-dimensional array with a single dimension array. That worked. Okay, but for broadcasting to work, it is important that the shapes on which we are doing addition or multiplication or any other kind of operations, those shapes should be compatible with each other. Okay, so now let's take this example. Here the first Numpy array is of 2 row and 3 columns. The second Numpy array is of 3 row and 2 columns. Let's see if we can broadcast operations between these 2 arrays. Okay, so let me run this cell. As you can see here, Numpy is throwing a value error. It is saying operands could not be broadcast together with shapes 2 cross 3. Okay, this is 2 cross 3 and shape 3 cross 2. So we can't do a operation of these 2 shapes, 2 row 3 columns and 3 row 2 columns, because they are not compatible with each other. So whenever this kind of issue happens, you need to fix it in your code. Okay, and you need to be aware that broadcasting may not always work on all the different dimensions array. Okay, those dimensions should be compatible with each other. So 2 cross 3 is not compatible with 3 cross 2. Now if we change 2 cross 3, I will keep the first array as 2 cross 3, and change the second one as 3 cross 3. Okay, even this one is not compatible. Now let's change it to 1 cross 3. Okay, this one is compatible. So you see no error in here. So this row first get broadcasted on this row of the original array, and then this row gets broadcasted on this second row of the first NumPy array. Okay, so that's how it works. So you need to be mindful when you are doing a broadcasting operation that broadcasting operations happens on compatible shapes only. So far I have shown you that broadcasting happens on the rows. Okay, now I will show you an example where broadcasting will happen on the column. So based on the shape of the NumPy arrays, it will be decided where the operation will happen. Okay, so here we have a 3 cross 3 NumPy array, 3 rows and 3 columns, and here we have a NumPy array of 3 rows and 1 column. Okay, now if we do the broadcasting operation, okay, how it will work? You can see this is a 3 cross 3 NumPy array, this is a 3 cross 1, that is 3 row and 1 column. Now what will happen? 10 will be added to, so this whole column will be added to each and every column of the original array. So this is the first column, this is the second column, and this is the third column. So look at the results. 14 plus 10, 24, 14 plus 10, 24, 18 plus 15, 33. So this column gets added into the each element of this column. Okay, corresponding element of this column. Similarly, again this column will add to this whole column. Okay, element wise. So 16 plus 10, 26, 9 plus 10, 19, 23 plus 15, 38. Similarly here. Okay, so broadcasting may happen on the row, but it may happen on the columns also based on the shapes of your input NumPy arrays, right?